All right, let's talk about the verify problems. Verifying or proving just means we've got an equation and we're going to prove or verify that one side equals to the other side. Now, the only big rule about this is you can only work on one side. You can't cross multiply. You can't divide both sides by something. You have to take one side and make it equal to the other side without changing the other side. So in a lot of cases, you'll have a problem like this, where it basically looks like a simplified problem. You just already know the answer. And that's kind of what I always say about this with the verify. The verify is actually a little bit easier than the simplify because you already know the answer. You just have to be able to prove it or show it. So when it comes to grading these, I'm grading your work. So you already know the answer, so I'm grading your work. And it's not like proofs in geometry where you have to write the reasons for what you're doing. You just show that you know what you're doing. Now, in most cases, you'd say something like this. I hate to use the word obvious, but you'd say, I definitely want to take the more complicated side and make it equal to the simpler side. It's easier to take something complicated and simplify it a little bit. So if I'm looking at this, I'm going to say, I don't know what to do here. But I could say, well, if I had cosecant and cosine squared, cosecant would be the same as sine on the bottom. Cosecant would be the same as sine on the bottom. And then you think to yourself, well, wait a second. If I had a common denominator here, if my common denominator was sine, my common denominator was sine, then that would become sine square. If I had to put a sine, if I put a sine right there, that would be sine square. And the reason I'm thinking that's such a good thing is because then I can say cosine square plus sine square. And hopefully at this point, a lot of this stuff is kind of automatic to you. Cosine square plus sine square is 1. And what do you know? 1 over sine square equals, I'm sorry, it's not sine square, it's just sine. 1 over sine is cosecant. So you took one side and you made it equal to the other side. All right, here's an example that actually uses the odd even identities. So the idea here is you got, oh no, tangent is a negative, which means you got to bring the negative out front. So negative tangent x. Oh no, tangent is an odd function. So you bring the negative out front. Sine is also an odd function. So you bring the negative out front. And wait, negative is just going to make a big old positive. And then cosine is an even function, so you can just essentially drop the negative. So the idea was tangent negative x, you brought the negative out front, made it tan x. Sine negative x, you brought the negative out front, made it just sine x. Negative, canceled and made it positive. All right, we've seen this. This problem is just the reverse of the previous problem. See, that's going to be sine over cosine times sine over 1 plus cosine. So we get sine square over cosine plus cosine. And you're going to say, wow, if I made a common denominator here, if I made a common denominator of cosine, then that would have to become cosine square. Oh, what do you know? We get that same situation again. We get that same situation of sine square plus cosine square, which we're all saying, yeah, that's equal to 1. So 1 over cosine, which we know is secant. So we end up with secant equals secant. Okay. All right. So here's a case. So I wanted to do this because you're looking at it and you're saying, well, which side should I work on? Which side should I work on? So I'm thinking, I don't know. Which side should we work on? These are, kind of messy. So one person says, well, I'm going to work on the right side. So you're thinking to yourself, well, I got sine square, but I need, let me see, that's going to be 1 over cosine minus cosine. How can I get, first of all, how can I get a minus sign in here? How can I get a minus sign in here? How can I get rid of that sine square and maybe make some cosines? Somebody says, well, wait a second. I could turn that into 1 minus cosine square, because that's what sine square is, over cosine. Wait a second, I've just got that one term in the denominator. So I can split that like this. So 1 over cosine, we've had this conversation before, 1 over cosine is secant, and then cosine square over cosine, one of the cosines cancels and just leaves secant. So that worked out pretty easy. But somebody else says, no way, I didn't want to do it like that. I wanted to work on the other side. Okay, let's see what happens if I work on the other side. So remember, you only have to do it one way. You don't have to do this two ways. So another person says, I'm going to do it this way. I'm going to say that's 1 over cosine minus cosine over 1. You're going to think, well, if I had a common denominator, just like we had on those problems on the other side, if I had a common denominator, my common denominator would be cosine. So I need times cosine. That makes cosine square. So what do we have now? We got 1 minus cosine square. Since I've got a common denominator, I'm putting them together over cosine. And then how convenient, 1 minus cosine square we know is sine square. So two different ways to work this problem because it wasn't as clear cut which side we ought to work on. So two different ways to approach that. All right, so what I'll do is I'll do a couple more problems that are a bit more complicated, but I'll do a separate video for that.